All right, and 3.8, factoring special polynomials. So this one here are specials. So we've done our factoring, but these polynomials are special. There's a bit of a shortcut that we can do for them, and it's good. When we see it, it makes it a quick factoring. It's just getting used to identifying them properly. That is the trick for this section. So the first one I'm going to show you is a difference of squares. And it is perhaps one of the easiest to recognize because there are only two terms and both of them are squares. So something here, x squared minus 9. X squared is a square and 9 is a square. This other example too, 16c squared minus 25a squared. That's also a difference of squares. 16 is a square number, 25 is a square number, and c squared and a squared, since they literally all are squared, they are a square letter, I suppose we could say. And of course, the difference section, they are being subtracted. So I'm just going to do the shortcut here, and then I'll explain why it works. So what we need to do, we're going to put it into a binomial, two binomials multiplied together. I'm going to take the square root of this term, square root, so it's just x and x, and I'm going to take the square root of the second term, so that's 3 and 3, and I'm going to add 1 and subtract 1, and I'm done. Right, that's all I need to do with this factoring, and let me prove it to you. Let's go in red and verify. And do this multiplication. Well, x times x, x squared, x times negative 3, negative 3x, 3 times x, plus 3x, 3 times negative 3, negative 9. These cancel out, really, negative 3x plus 3x, x squared plus 9. Boom. Right, that's how that works. Because one's positive, one's negative. This middle term cancels out completely. It adds to 0. And we're left with just a square minus the other square. And that's it. That's all we have to do here. So this one here, let's just do it. The square root of 16c squared. Well, the square root of 16 is 4. And the square root of c squared is just 1c. And then the square root of 25 is 5. The square root of a squared is a. So 4c plus 5a and 4c minus 5a. And that's it. That's how we do a difference of squares factoring. We just need to identify it and remember our rule, which is the square root of each term, and then one we add, one we subtract. All right, our perfect square trinomial is also a nice one. We can factor this using our regular factoring, but we're going to notice something kind of special about it. So what I'm saying here, so it's x squared plus this 2 times the square root of c plus c, where c is a perfect square. All right, I know how much you love it when I use letters unnecessarily. So let's just look at an example here. Let's look at this one first, because the square root of 9, we've just talked about it. The square root of 9 is 3. All right, and notice that 6 is 2 times 3. And so if I'm building up this, you cut it off from seeing it. If I'm building that, 6 is 2 times the square root of 9. The square root of 9 is 3. So what I'm going to end up getting here, I'm not going to tell you what I'm going to end up getting here yet. Let's just factor it how we usually do, but let's just sort of keep this in mind. So my usual factoring rules would mean that I need something that will multiply to 9 and add to 6, right? That's my basic factoring. And I know 3 times 3 is 9, and 3 plus 3 is 6. So 3 is my special number. I've got x plus 3, x plus 3. Okay, well, I can simplify this even more, because x plus 3 times x plus 3, that's x plus 3 squared, right? It's a perfect square trinomial. It is, when we factor it, it's just one factor squared. All right, let's look at this next example here. So 36, that's a square number. So when we start looking at factoring, I want you to look at the last number. Is it a square number? If it is, start getting excited because you might be able to take a shortcut. Is this 2 times the square of that number? Well, 12, that would be 2 times 6. And 6 is the square root of 36. So this would be x plus 6 squared. And again, that's it. All right, this is a shortcut. We can always do the perfect square trinomial factoring regular, but we don't need to. Right? We can just see square root of 36 is 6, and 12 is 2 times 6. So we've got the perfect square trinomial. It's going to save us some work, some time, and it's just a bit of a nice shortcut there. Right, and that's it. That's how we factor our special polynomials. We've got the difference of squares and the perfect square trinomial, which have a bit of a special shortcut for us. And that's it. That's the end of our factoring, our multiplication. In fact, we're done the chapter, so it's time to get some practice in and do some review and be ready for your chapter test.